the race to win wars and explore the stars have created some of the most fantastic products ever designed, and we use them every day, unaware of their amazing origins. On Wicked Inventions. The bagpipes, the military importance of this haunting Scottish instrument. The jet engine, how a World War II technology battle led to the comfortable air travel we enjoy today. Helmets, how head protection was originally developed for battle. We reveal the amazing science and manufacture behind these wicked inventions. There is no instrument with a more distinct sound than the Great Highland Bagpipes. The rousing tones of the pipes are guaranteed to strike passion and pride into any Scots person whenever they are heard. But the history of the bagpipes stretches far and wide across the centuries and the globe. Nobody really knows when or where the concept of the bagpipes originated. Their usage spread across Europe over the centuries, and bagpipes were first recorded as being used in Scotland in the 16th century.
First recorded use of the Scottish Highland bagpipes, 1547, Battle of Pinkie, where they replaced the trumpet. They were then used to intimidate the enemy, to rally your troops, and to really give you a bit of backbone. You know, you can hear the skirl of the pipes.
Bagpipes became an important part of the Scottish warriors' arsenal for rallying the troops as they marched into battle. The distinctive sound is familiar the world over and has been heard whenever Scottish regiments have fought, from Waterloo to Afghanistan. Their popularity in Scotland began to fade from the 18th century onwards as a result of the English military victories against the Highlanders in 1746, which began to erode the traditional ways of the northern Scots. Ironically, it was the Scots soldiers, now in the British Army, who kept the Great Highland Pipes alive.
Tradition plays an important part in any army, and in the British Army we have deep traditions, and the bagpipes are one of them. You can be the farthest part of the world, on duty, soaking wet, cold, miserable, or roasting hot, and then you hear the pipes, the skirl of these pipes, and you are home.
The unforgettable drone of the instrument heralded attack after attack at victories such as Waterloo against Napoleon, the Battle of the River Alma in the Crimean War, and even against the might of the German machine guns in World War II. In Normandy in 1944, Private Bill Millen played his pipes as Scottish Lord Lovat's elite commando special forces battled German defenders on Sword Beach. Macallan bagpipes have been making the instrument in Kilmarnock, Scotland since 1998 and produce 40 sets of bagpipes every week.
We're producing just now about 10 different models of bagpipes, but within that 10 model of bagpipes there's so many different variations with imitation ivory mounts, horn mounts, mopani, African blackwood. We have 6 different engraving patterns, Celtic thistle, zoomorphic, Irish and so on.
Nowadays the Scottish Highland bagpipes are loved and played all around the world, including some very unexpected places.
We're very strong in most of the markets, obviously Scotland and the rest of the UK. There's the traditional markets, if you like America, Canada, Australia, New Zealand, Brittany and the rest of Europe is growing all the time. And in the Middle East, most of the countries out there play bagpipes, so we've become very strong there. I would say just about every pipe band in Oman is playing Macallan bagpipes and chanters. It is really now a worldwide market.
The last use of the Great Highland Pipes in battle was in Aden in 1967, but wherever British soldiers of Scottish descent march, you can be certain the Great Highland Bagpipes are never far behind. The bagpipes, truly a wicked invention. There are 4 main components which make up a set of bagpipes. There's the bag itself, which provides the air to the pipes, a blowpipe, which the piper uses to inflate the bag with air, the melody pipe, known as a chanter, which plays the notes by way of finger holes, and 3 other pipes, known as drones, that play harmonies tuned to the chanter pipe. The pipes are made from African blackwood. It's a very hard wood, which is perfect for constructing pipes.
This is the raw material. It's African blackwood, and it comes to us in a 14-piece set. It's harvested in Mozambique or Tanzania. First operation for us is to turn it till it's round, and really that's only just to make it easier to handle in the turning machines.
A hole is bored into the centre of the cylinder to create the pipe. This is known as gun drilling.
And then we would put it to one of our turning machines to give it a rough profile, and this is just really to allow the wood to stabilise.
The pipe is then profiled on a CNC lathe to create the classic pipe shape. These days, it's a precision process controlled by computer. A process called combing and beading decorates the drone by hand, using different tools on the lathe. The drones are finished with an application of wax.
We would then make all the alloy ferrules and mounts, which are made from solid bar, threaded, polished, and then engraved.
The ferrules are engraved using a computer-controlled CNC machine. These will be attached and glued onto the ends of the drones to provide protection and also decoration. The chanter is the pipe which plays the melody and is constructed from plastic. It is bored and profiled in a computer-controlled CNC machine to produce its tapered shape. The finger holes are also precision drilled. The distinctive sounds that the bagpipe produce are generated by the air passing through reeds, which are housed within the pipes themselves. The reeds are constructed by hand out of bamboo cane. They are tied together using hemp string and sealed using resin. Stocks, short, straight pieces of board wood, house the reeds. The stocks act as sockets, which attach the pipes to the bag during assembly. The 5 stocks are tied into the bag using hemp thread. The bag itself was traditionally made from elk or cowhide. Nowadays, the bags are made using synthetic materials with a zip for easy construction. The drones, chanter and blowpipe are slotted into the stocks using a hemp thread, which forms a good seal and can also be easily replaced over time. A decorative outer cover is applied, and the drones are held together using rope to hold them in position when being planed. Whether it is a rocket firing an astronaut into space, or an aeroplane flying you to your holiday destination, a scientific wonder is busy propelling us through the air. It is called the jet engine. We think of jets and rockets as a 20th century invention, but the scientific principle behind their action has been understood and studied for the last 2,000 years. It is called jet propulsion.
A jet propulsion system basically requires a fluid of some sort to be pushed out the back of a system, and then the system which is pushing it will move forward. This is because of Newton's third law. Every action has an equal and opposite reaction. So what happens is, as the fluid is being pushed out, in the case of a jet engine, it's air, that pushes back on the engine, and that pushing back on the engine is what moves the jet forwards. So for a jet engine, you push out hot gases which are combined from air and fuel being burnt. This air and fuel being burnt pushes out at a high speed, pushes the airplane forward, and thus you have the opportunity for flight, provided it's actually attached to an airplane.
Jet propulsion covers a wide selection of engines, from solid fuel rockets to the water jets that power jet skis. But the jet engines that we come into contact with most are the ones found on passenger planes the world over. In its most simple form, the jet engine can be broken down into 4 main parts: the compressor, the combustor, the turbine, and the exhaust. The compressor is comprised of a series of turbines that sucks in air and squeezes it as it flows across the turbine's angled blades. This action compresses the air and increases its pressure and temperature. Next, some of the pressurized air enters a combustion chamber, where it is mixed with fuel and ignited, which increases the air's heat energy. This powerful hot mixture rushes out of the chamber at high speeds and expands. It then meets the turbine and passes through its blades, and some of the gas's energy causes the turbine to spin. The turbine is connected to the compressor at the front of the plane, and this force is used to power it. Finally, the hot air is ejected through the exhaust. By now, the air's speed has dramatically increased, and this is enhanced further by constricting its flow as it enters the exhaust, which gives the air a final kick as it leaves the engine. This is the basic layout for an engine called a turbojet. The jet engine of today may be an intricate technical marvel, but you can see the principle that led to its discovery 2,000 years ago in your own home. When you boil a kettle, the steam rising from the spout is actually a very simple jet stream. It is obviously not powerful enough to make the kettle fly off the kitchen top, but a device called an aeropile was developed in the 1st century BC, which used this hot gas to create motion. This device directed steam through 2 nozzles, which generated thrust to cause a sphere to spin rapidly on its axis. Well, the aeropile did not seem to have any particular practical benefits, but it did demonstrate how expelled hot gas could power an object. So we know how a jet works, and how the physics was discovered that understood the principles behind it. But where does warfare fit in? Well, the development, that's where. By World War II, piston-propped propeller aircraft had been well established over the battlefields of the early part of the 20th century, but they had their limitations. At very high speed, aerodynamic problems could result that could tear props apart, with disastrous results.
The limits for a propeller aircraft are basically the limits on the propeller itself. As you spin something faster and faster, the tips of the propeller can start to approach the speed of sound. The reason that the speed of sound is important is that as any object approaches the speed of sound, it starts to generate a shock wave. And a shock wave generates turbulent air. A turbulent air isn't actually that efficient for flying. So in order to get around that, the basic problem is you're using a propeller to move air, which is a fluid. That fluid is causing you problems because you can't move it any faster. So either add more engines or change the engine type. When you change the engine type to a jet engine or a gas turbine, you're trying to push the air out in one efficient motion rather than trying to claw through it as in a propeller does.
While the theory behind gas turbines has been understood since the late 18th century and a patent filed for a jet-powered aircraft in 1921, no one had actually been able to build a practical example. But the pressure to win World War II soon put paid to that. In the late 1930s, a race developed between British engineer Sir Frank Whittle and his German rival Hans von Ohain to develop a reliable jet engine that could power a war-winning aircraft. While both men took slightly different approaches, they both followed the same basic turbojet design. In the end, the race to be the first to introduce a jet-powered aircraft into combat was narrowly won by the German Luftwaffe, which introduced the Me-262 in April 1944. Swiftly followed by Britain's Gloucester Meteor 3 months later. Both planes had little effect on the outcome of the war, but the jet had now made a massive advance in aviation technology, and the skies had been changed forever. So there you have it. This radical piece of aviation technology that we use every day was a direct result of efforts to gain air superiority in World War II. The jet engine, truly a wicked invention. The principle of the jet engine seems pretty simple in theory. Suck in air, compress, ignite, and the result, thrust. But how easy is it to build your own power plant from everyday items? Undaunted, our intrepid tester is going to find out. The materials you will need: 2 toilet brush holders, toilet brushes optional, a small electric fan and battery, metal tape, assorted tools, and a bugle. More on that later. To begin, we will need to construct our main combustion chamber out of our toilet brush holders. This involves a lot of hammering, bending, welding, blood, sweat and tears, so this is one we made earlier. The chamber is designed with a tapered end, so the airflow and exhaust gases are compressed as they exit the engine to provide additional thrust. At the front of the engine, our bugle has been pressed into service as the air inlet into the combustion chamber, with its narrowing side squeezing the air that enters. Now, how much air can we suck into our jet? Using an anemometer, which measures airspeed, we plug in the electric fan and measure the results. An airspeed of approximately 6 meters per second. Will that be enough? We attach the fan to the front of the jet to let it mimic the compressing job of a turbine, and with a firework lighter acting as a simple ignition system, squirt our fuel into the combustion chamber, and boom, we have a flame. But is it really a jet? I'm not convinced. But we do have fire. Time for a rethink. We're going to need something with a little more blow. An industrial leaf blower, perhaps. On a low setting, the leaf blower blasts out a meaty 18 meters per second wind speed, 3 times the power of a small fan. But will that be enough to fuel our jet? Let's find out. We attach the leaf blower to the jet, turn it on and ignite the fuel. Now that's more like it. For a split second, we have a clean hot jet powering out of our exhaust. Okay, it might be more flamethrower than working jet, but our little homemade engine demonstrates the effect that air under velocity mixed with fuel and combusted provides a great deal of thrust. So, back to our original hypothesis. How easy is it to build your own jet engine out of everyday items? The answer? Not very. From firefighters to builders, the helmet is used to protect people's heads in potentially hazardous situations. But this everyday safety essential can actually trace its roots to history's bloody battlefields. The first known use of the helmet dates back to the Syrian soldiers of 900 BC. The need for the helmet was apparent to the first armies. The head was the most fragile part of the human body, and therefore something needed to be done to protect the soldiers in battle. The helmet was the answer.
One of the problems with the early helmets for the Greeks, for instance, was they literally were so heavy and covered the face, hard to breathe. So many of the illustrations from the ancient times show you that the Greeks pushed their helmets back to have an open face. And then you see with the Romans, the actual front of the face was open, exposed, although they did have the cheek guards. But as you go further into history, the Saxons, they did without it. The Normans just had the nose guard. It's important to be able to see and to breathe.
Helmets have been made out of a variety of materials: metals, plastics, leather, and even modern-day Kevlar. However, some more novel materials have been used. For example, the ancient Mycenae of 1100 BC used boar tusks. During the 19th and 20th century, leather helmets were widely used by the military, especially by aviators and tanker crews.
One of the problems with protective headgear is finding that balance between protecting your head and wearability. Can you wear it comfortably? Is it safe to wear it? Will it protect you?
Despite their military history, helmets have been used by the civilian population, either for sporting events or for everyday protective use. The helmet has evolved with the advancement of technology, and they became lighter, stronger, and more comfortable. We see them or use them every day, from cyclists to construction workers. The helmet has been so reliable that it's no wonder it has been ever present for thousands of years. The military still uses it to this very day, and has become a fundamental piece of protective gear for our everyday life. Another way that this military hardware has found its way into our lives is through its use with the police. Since the foundation of the first British police force, Christie's of London have been the designers and sole manufacturers of this truly wicked invention.
To make a police helmet takes approximately between about 45 minutes to make from when you add together the many processes that are involved. We make many thousands of them every year, but it very much depends on police budgets and police numbers as to how many we actually are required to make. The process is, involves many components, most of which are sourced within the UK, and we manufacture from scratch the helmet here.
The initial process begins with the making of the helmet shell, using a vacuum moulding machine and a metal mould. A sheet of ABS plastic is heated and then lowered over the mould, where a vacuum pulls the plastic into shape. It hardens instantly, and then a rubber mallet is used to release the plastic from the mould.
So it's called a custodian helmet, So that custodian helmet shape was created in 1863 by the Metropolitan Police again, and sort of over time other forces took on that same shape, recognised that it was a perfect shape for what they wanted, but it wasn't actually until 1930 that the government made that the core specification for all police helmets throughout the UK.
Two outer excess layers of plastic around the brim of the helmet are trimmed with a bandsaw and then sanded down. Removing any further excess with a knife.
It wasn't until the mid-80s, the late 80s in fact, after the miners' strike, that they moved to ABS. So it was cork from 1930 through to the mid-80s, and then from the mid-80s onwards it became the ABS that we see today.
The helmet's fabric covers are made out of a water-repellent wool that are cut in halves and stitched together. Glue is applied to both the inside of the fabric cover and the outside surface of the helmet shell. The fabric cover is then steamed and stretched tightly over the shell to prevent any bulking. A wooden tool is carefully used to smooth away any air bubbles, as well as to ensure the fabric cover is in full contact with the helmet shell. Any excess fabric is then cut away.
We do get requests all the time from the USA, so Calgary police come to us, St Lucia. In fact, sort of a number of the Commonwealth countries you will find they still have some need either for a ceremonial helmet, or indeed their police force still do use the classic custodian helmet. Nonetheless, it's where it is the iconic look of a police force or a ceremonial look, they don't want to lose that.
Once dry, the adjustable head harness is made out of strips of fabric tape and foam stitched onto a plastic headband. This is then inverted so that a modern pattern chin strap can be also stitched on. Black plastic piping is sewn around the brim of the helmet to reinforce it and give a neater edge. Nearing the end of production, holes are drilled on the top, sides and front of the helmet, and an appropriate police helmet plate is screwed on. The harness assembly is lowered into the helmet and secured with an industrial stapler. The narrow chrome metal band is wrapped around the helmet and pinned down, concealing the staples.
Each helmet is tested to a specific standard. It's called the EN 397 and it was last revised in 2012. So EN 397 2012 is the standard we test to, is otherwise known as the helmet standard. It requires penetration protection, so it has to achieve a certain level of protection against a certain force, a spiked force actually dropping down on top of it to protect from impact from the top. And then secondly, the actual movement of the hat, if you like, or movement of the head. So it doesn't want to translate any impact that it's received on the helmet. It needs not to translate through to the head itself. So it needs to absorb some of the impact that, of that force passing down on top of it. And that's basically the test that it passes.
At last, the helmet is labelled and given a good brush. It is now finally ready to be shipped on to an awaiting police force. So there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day, but have never realised their amazing background. Bagpipes, the jet engine and helmets, all wicked inventions.